Okay, so we got a right triangle as side lengths 5, 12, and 13 shown below. Use these side lengths to find cosine B, tangent B, and sine B. So some quick definitions. Sine of any angle theta, could be angle B, like in this case, is going to be what's opposite of theta. I'm going to abbreviate. Divided by the hypotenuse. Okay, and then cosine of any angle theta is the adjacent. We'll talk about what that is in just a second. Of theta divided by the hypotenuse. And then tangent theta is the opposite over the adjacent. Okay, might have heard of SOHCAHTOA before. Okay, so that's SOHCAHTOA means sine is the opposite of our hypotenuse, the so part. Cosine, ka, tangent, toa. That's just a way of keeping those straight. So for this triangle here, they're talking about angle B. So we're looking from angle B's perspective. Because look, what's opposite of B is the side 12. Now that's different. If they said sine A, then the opposite would be 5. So that's why it's important that we think about the angle we're referencing. Okay. So to do these three ratios, the way you figure out, they ask for cosine first. So the way you figure out the adjacent is that through a process of elimination. So for cosine B, what's opposite of B is 12. So that means 12 is not the adjacent. And the hypotenuse of the triangle is always the thing across from the right angle. So 13 is the hypotenuse, meaning it's not the adjacent. So 12 is the opposite, 13 is the hypotenuse. That means 5 is the adjacent. And 13 is the hypotenuse because that's what's across from the right angle. We'll do the same thing with sine. From angle B's perspective, opposite of angle B is 12. The hypotenuse is still 13. And then for tangent, it's opposite over adjacent. So opposite of B is 12. The adjacent we said was 5. So those are the three things you need here. Cosine B 5, 13. Tangent B 12, 5, 12, 13. Let's see if it's any different in the next one. No, same type of thing.